Today we're talking about the neuromuscular system. We have a brain, and inside that brain we need to understand the blood-brain barrier. We have a capillary that brings in blood flow and nutrients to the brain, but we always say, what is this blood-brain barrier? That's where this cell called the astrocyte attaches to the capillary and then attaches to a neuron, and these are over here as well, to provide what? A filter system to allow the nutrients to pass, but we can't allow chemicals that would destroy these neurons. If we did, we would never survive. So the blood-brain barrier is really the astrocyte. You should just call it the astrocyte instead of the blood-brain barrier and say the astrocyte will not let certain drugs or chemicals that could harm the neurons get through. What are our three main chemical receptors, neurotransmitters? Norepinephrine, serotonin, and dopamine. Must remember these in general because we have dopamine and then the reuptake inhibitor that will tell us to turn off the dopamine. We have norepinephrine, which will, based upon alpha stimulation and norepinephrine reuptake, it will tell us to make more or not. And then we have serotonin. The simple scenario is, when you think about it, if we have a lot of anxiety, we have a lot of norepinephrine, which gives us the shakes and the adrenaline surges. We don't have a lot of GABA, so we have a lot of fear and anxiety. And then the 5-HTP, which is our serotonin, is dealing with our depression or in general how we feel about that moon. Depression has no norepinephrine. That's why people with general depression do not have function. They do not want to get up and move. They do not have a happy mood. And their dopamine is low, so they don't even feel very comfortable. They're mostly sad, depressed, and no energy. Alzheimer's is dealing with the acetylcholine. That's the main neurotransmitter that helps us produce these chemicals. So when we don't have enough acetylcholine, we don't even have the chance of producing dopamine. Schizophrenia is an increase of too much dopamine. So we deal with the anger issues of dopamine, which turns on these neurons and gives us thoughts much more of anger, which is dangerous. And then Parkinson is a decrease in dopamine, increase in serotonin. So we have an interesting argument with dopamine and how we move, because this provides slow, smooth muscle control. So when we have lots of dopamine, we can do nice, slow movements. When we don't have enough dopamine, we look like Parkinson's, where we have short, choppy motions. About the spinal cord, you need to know that it is a hardwired pathway for arms, legs movement, transversing, ascending, descending signals that come out of the brain. They're just there to provide what? A signal. That signal comes from this neuron that then travels down through the spinal cord out what? A peripheral nerve that is encompassed by Schwann cells, and we have the node of Ranvier, and that's the things in between this. So this turns on, and the signal will keep passing along the peripheral nerve. All this is coated with what we call myelin sheaths. So anything that attacks the myelin sheaths, such as MS, will not allow the proper nerve signal. And then when we get to the nerves that are out in our hands and fingers, it's uncoated. So what happens to a muscle? We have the nerve response. We need calcium in our system. The calcium is absorbed from the ECF into the synaptic cleft. The acetylcholine then turns on the receptor to allow the calcium to be absorbed and go into the troponin of the muscle, or that's mainly heart muscle, tropomyosin of the skeletal muscle, to create what? A muscle contraction. So we must have the nerve signal to then create the calcium absorption into the synaptic cleft to then allow the sodium-potassium ion gate to absorb calcium into the muscle to then allow the muscle to contract. This is how, in general, why if we have low calcium, we will have flaccid movement. If we have high calcium, we will have hypertonic or, I'm trying to think of the word, but tetany, where the muscles are severely spasmed. So in general, if you can remember that the cerebral spinal fluid is the coating on the outside of what? The spinal cord. The spinal cord is hardwired for certain pathways up and down that do not change. So remember that dopamine is the angry and blunt. So if I'm really angry, I have too much dopamine. And if I'm kind of blunt and just I have no care in the world, then I don't have enough dopamine. Serotonin is the happy and sad. Okay? And I want you to remember that all nerves are coated with myelin sheath that comes from the Schwann cells, and anything that attacks that will create a nerve signal problem, so our muscles will not be able to absorb the calcium from the synaptic cleft and contract right. The other thing you need to remember is the blood-brain barrier, where the astrocyte is at, and it's really the astrocyte is the blood-brain barrier that filters the blood to go to or allows certain nutrients to go to this neuron, otherwise we would destroy this. And these chemical signals influence how we think, how we feel, and what we want to do. What does that mean? If I'm in a happy mood, I want to go exercise, so I will have all these flooding. If I do not have a happy mood, and the serotonin is low, and maybe the dopamine is low, then I won't have as much So it changes my thoughts as well as my motion, all in the brain. So that's why you see physical and mental disorders together, and you have those symptoms mixed together. All right, in general, the parts of the brain that you need to know, this is the reasoning part of the brain, this is the speech part of the brain, this is the movement, and this is the eye. So if I happen to have a stroke back here in the posterior part of the brain, hopefully in the higher part, not in the medulla, I may have trouble with my vision. Mainly strokes are going to happen right here in the movement area. So you will see it ipsilateral. So if my right side of my brain has the stroke, then my left side of my body won't move correctly. A lot of times that runs into the speech area as well.